Back to the lecture number 9. Today we will talk about polymorphism, static or the compile time polymorphism, function and methods overloading. We talk about virtual methods and their properties, hiding base class member via new, and then sealing virtual members, accessing base class members in the derived class. These are the contents that we will cover in this lecture. So the first is polymorphism, Greek word that's come from many shaped. So the meaning of that particular specific polymorphism is the many shaped. At runtime, derived classes objects may be treated as an object of a base class. So that is something which is we need to elaborate further. When we look at the examples, then it will be clear that how we can have like derived classes, we create the object, but we are considering them as the object of the base class. We will see when we have the examples, and then it will be more clear. So base class may define and implement virtual methods, and derived classes can override them. So in the base class, the parent class, we have the virtual methods. In the virtual methods, we can just give either we can override mean that we can give a different implementation in the child class. Base class objects invokes virtual methods. So base class object can have the virtual method, but derived class method is executed. So based on that particular specific, what you can say that we have assigned the base class, the object of a derived class, to the base class, and then we are actually calling the base class method, which has been override, which has been changed in the derived classes. But when we are calling the base class method, actually it called the derived class method. So I will give you the example when it will you will see the code and then how it is being executed, then it will be much more clear. So this is an example that we have been following throughout this course. We have a shape 2D, that is a child class of the shape, and in the shape we have a name variable which have the name of the shape, and then we have the constructor. In that particular specific constructor, we have provide the name, and that is passed on to the base class. We also have the abstract methods. Abstract methods are those methods which need to be implemented. We have only given the header. So we say that what is a public, it's an abstract method, what is the return type, what is the name of the method, and so these are the methods that need to be implemented in the child class if that class is not virtual. And then we also have the virtual methods. They have the implementation or the default implementation of those methods, print shape and the draw shape. So as you know that when we talk about the print shape and the draw shape, these two methods has to be changed. The reason is that if we talk about shape 2D, two-dimensional shapes, then we have circle. Printing a circle is a different way. There we need to print the radius of that particular specific circle. And then if we talk about square, then we only need to print one side of that particular square. If we talk about rectangle, then we can have to have the length and width of that particular specific print something on the screen. So the related information based on that particular specific two-dimensional shape that is changing from shape to shape. So these methods must be overridden or should be overridden in the derived classes or in the base classes. So these are defined as virtual. And then again here we have another virtual method which is a draw shape. Again, based on the shape we need to draw a different shape on the canvas. So here we have a square class, which is the child class of the square 2D that we have just seen. Here we have one floating side, that is side, and then we have public square string. We are actually creating a constructor which is taking a string value as an input, and then it passing out to the base, and then base pass out to the shape class. Then again we have another constructor which take two parameters as a input. One is this name or string name, and then the other one is this side. So side has been assigned to the side part, and the name is given back to the parent class, and that gave us again to the shape class. And then we have override the abstract methods area and the perimeter, and then of course you know that we take the square of the side and we get the area of the square. And then if we want to find out the perimeter, the boundary wall length, then we can simply multiply by 4 with the side, because we have 4 sides, and then if one side length is this, we multiply by 4, we get the perimeter. And similarly we have the print shape. And if we look at that particular specific thing here, at this particular base dot print shape, so now we are not only calling this particular specific method, but we are also saying that in the method we are also calling the parent class, the shape2d print shape method we are calling. So we can access the shape, the parent class methods, or the base class method, like base dot whatever that method you want to call, or whatever property that you want to access, you can write that thing here, and then in this way you can access the base class methods and the properties. And then of course we are writing that we are side of a square is this, and then we are also draw shape method, but again that was a virtual method. We have override, we have changed that particular specific method in the derived class. So here how we can use it. If we this is simplest way to do the things. We have a new square, and we are creating a square object of the square. But on the left side, if we look at that, we have a shape2d, and if we go back to our shape2d class, this is an abstract class, as we have discussed earlier in our previous lectures, that we cannot create the object of a abstract class like new shape2d and then calling the constructor. No, we can't do that, because this class has been defined as abstract. It means that we cannot create its object, but we can create a reference type variable. Here we say the shape2d. When you say reference type variable is representing a address of the memory area. That memory area can consist of anything. It can be an object, it can be an integer value, it can be a double value, but that is actually representing the address of a memory area, and that is called a reference variable. So reference variable we can create even for the abstract class, but we cannot create the object like new shape2d and then pass the name of the shape. We can't do that. So here on the other side we are creating the object of the square, which is a derived class, which is a child class, and we are assigning it its object, the object of the child class, we are assigning it to the reference type variable of the parent class, that is the shape2d. And if we go back to this particular specific point, derived classes objects, the parent child classes objects may be treated as an objects of a base class. So we are not creating the base class object, we are creating a base class reference variable and assigning it the object of the derived class, and that is exactly what we are doing here. Okay, and then when you say shape2d dot print shape or shape2d dot draw shape, actually it will not going to call these methods which are present in the shape2d class. Rather it will call these method which has been overridden, which has been changed in the derived class, because the object is of the square class. So square class object in these method has been overridden, so they will call this methods, not the base class method. So when we execute this particular specific code, this main method, it will give us name of the shape is square, that is what we can say that print shape, and then we have a side of a square is 4.5, and then we are saying that drawing square shape. So if we look at that in the print shape method, we have actually called the base class print shape method. In the base class print shape method, we are just saying that name of the shape is this, and that is exactly what this particular specific line print. The name of the shape is square, and then the side of square is 4, and that is what we are getting here. So this particular first line is coming from the base class print shape method, and the second print line is coming from the child class or the square class print method or print shape method, and then of course we are drawing the square shape. So this is a little bit polymorphism. Static or the compile time polymorphism. So method functions, as you know that we can define the methods which has the same name but they must have different number of parameters or maybe different type of parameters. For example, here if we look at that int a, int b, here we have a long a and long b. So two parameters, but they have different types. So based on the input values, it will decide that which specific method need to be executed, and that is done on the compile time. And when you're compiling this particular specific method and you have called add method with different type of values, then it will automatically select which method should be called according to the number of parameters and the type of the parameters. This return type does not change anything in that particular specific factor. Okay, so and the other thing that I would like to say that here we are giving that these methods in the lambda expressions. So here we say equal sign and then greater than sign and then a plus b. So what does that mean? It means it will return the addition of a and b. It will add a value of a and b and return the value back to the, and the same thing is happening here. It add the values of a, b, c and return them. It will add the value of a, b, c, d and return them, and so on. So these are the lambda expressions. These method has been given in the lambda expressions, and when we have the expressions, when we have the method which are quite simple, then we can write these kind of lambda expressions that will reduce the number of lines that we need to write, and it will simplify the code, you can say that. So this is our methods which has been overloaded, okay, with the same name but different parameters and types. And here we are creating the object of that particular specific class which contain these method of the same name, and then we have int result is equal to overloading dot add. We are give 2 parameters, we give 3 parameters, we give 4 parameters, and as you know that when we are giving only the complete numbers, they always considered as integer by default inside the Java. So they are considered as integer values. So we have 2 integer value, 3 integer value, 4 integer value. So this particular specific method automatically linked to the first one, and this one is linked to the second one, and this one is linked to the third one. On the other side, if you talk about the long values, by default these 34 and 78 should be considered integer values, but now because we want them to be considered as a long values or the big integers, then we have to put a capital L at the end. So once we have assigned this thing, it will automatically consider that these are the 2 long values, so it will automatically connect that particular specific call to this method. So it will calling based on, wherever we are doing this particular specific add method, it will automatically call this method rather than this one. So same. So this is the static or the compile time polymorphism. When we are compiling our program, it will automatically link these calls of the add method to different methods within that particular method overloading class. Okay, so this is our static or the compile time polymorphism. So virtual properties, what do you mean by virtual properties? We have seen the virtual methods. If we look at that, actually we are saying that it's a public virtual int, and then we have sides, and then we say get return 0, how many sides that particular specific shape has. So normally we can say that these are the get and set methods, get sides or set sides. So here we have given this what we can say that simplest way to access those public properties. So we have this public virtual int sides, and we have get return 0. So actually it is a method which has been defined as a property inside the shape class. So that method has been defined virtual. It means in the child class we can override that particular specific property. The reason is that we know that in the circle, this property does not need to be override because we have 0 sides. We have only one value that we need to consider there, that is the radius. And on the square we have all 4 sides, so we can see that in the rectangle again 4 sides, in the pentagon we have 5 sides, in the hexagon we have 6 sides. So based on the shape that we are talking about, two-dimensional shape we are talking about, these number of sides will change. So we need to override that particular specific property in the derived classes. So let's talk about the square. So again square 2D, so we can public override int side. So we are overriding that particular property which has been defined in the shape 2D, and then head we say that get return 4. So it always give me the return for whatever the particular specific sides. It will say that yeah, the number of sides are 4. So we can simply say shape has shapes 2D dot sides. So it will print that particular specific shape has 4 sides. So this is what we can say that these are the visual properties. Hiding the base class with the new. What does it mean? So we have the base class shape 2D, which is again the child of the shape class, and then we have the shape 2D constructor, we have the abstract methods area and perimeter, then we have the virtual methods draw shape and the print shape. So that is the same that we have defined earlier. Now in the square class, instead of overriding, instead of saying public override void draw shape, we say public new void draw shape. As you see that we have a draw shape method in the base class, and now we are defining the draw shape method in the child class, but we are using the new keyword. So what will happen here? So when we are again doing we are creating the square class object, and we are assigning it to the shape 2D, the parent class object, a parent class reference variable, not the object, parent class reference variable, and then we are calling the print shape and the draw shape method. And now as we say that, we are say that this public new void draw shape, it will disconnect the relationship between the parent class and the child class. So it is considered as a new method which has been defined in the child class with the same name as a draw shape method in the parent class. So now what will happen here, instead of calling this method draw shape method here, it will call the parent class or the base class draw shape method. So if we try to run this one, it will say name of the square is name of shape is square, that is coming from this print shape method. Side of the square is 4.5, that is print shape method, because we are calling the base class and the child class methods. And then here this is actually calling this draw shape is actually calling the this method drawing shape 2D, okay, and it is not calling this particular specific method. Even we are saying so we have certain limitations within the shape 2D class. Maybe in the square we have more methods if we are not defining that this is public override new draw shape, but these method, draw shape method, print shape method, perimeter method, area method, even the side is present, side is not present inside the what you can say that side is not present in that particular specific thing, so we cannot access that particular specific underscore side in using the reference variable of the base class. The reason is that that is not present. So anything which is already defined, already present in the base class, that is the area, perimeter or the print shape, we can access those methods. And because here we disconnect that particular, we are considering as a new method in the child class, so we cannot access this method using the base class reference variable. So if we are using the base class reference variable, then we can only access those methods which has already been defined in the shape 2D class. Yes, we override, we change, we give the implementation in the child class, but they has been defined over there. They are visible to that particular specific reference variable, and we can access them. If we have like more three new methods here in the square class, then we cannot access them using the shape2d class. So if we want to access them, then we also need to create a reference derived variable of the square class rather than the base class or the shape2d class. So again, if you want, if we say we creating a object of the square class, and then we are assigning it to the reference variable of the square class itself, then when we say that square.draw shape, it actually call this particular specific method rather than the base class method. Sealing the virtual members. So in the shape we have the string name, we have the name, we have print shape, we have draw shape methods, okay. And then in the shape2d class, again that is an abstract class, we have given the override those virtual methods, okay. And then we also have, so we override one method, we don't need to override all the methods, but we have only overridden one specific method, okay. And then in the child class, we have completed that implementation. So because we have completed that implementation, there will be no further subclasses or the child class without the square. So we mark it as a sealed class. It means that we cannot create another class which is the child of the square, because we are saying that it is a seed class. It cannot be further can have the child class. So there is no further inheritance is allowed on this particular specific class, because we have defined it as a sealed class, okay. So now base.parent, so that is, I mean, this is what we can say, that how we can stop, and that this is the final class. There is no further inheritance is possible with this class. So if that is, we want to implement that, we want to ensure that thing, then we are say public sealed class. So now if we try to write a specific class, if I just try to like say that I say that it is difficult to write with these, class my, and then we can say that square, we have this square class. Now this is not possible. The reason is that this particular specific class, that is square, is sealed class, so it cannot be a super class of any other class. It cannot be a parent of any other class. So that is the purpose of the what we can sealing the virtual members. We can also have sealed override, so we can stop that this particular specific method. We can say class, we can also say the method as well. So the method sealed override, it means that it cannot be further changed in the derived subclasses. So we can either seal the class, or we can also seal the methods, virtual members, or virtual properties of virtual members, virtual methods. So in this way we can stop the changing of the implementation in the further child classes, or any more changes are required. So we can stop that particular specific process. Base class, we can access the base class members. For example, we say that if we are in the print shape method, we actually calling the shape2d method, that is the print shape. So if we don't write this line, it means that we cannot access that particular specific shape2d, because we want to execute that particular specific method, and then we print further information about this shape. So that's why we can use simply base dot name of the property in the base class, and then we can access it. So this is how we can access the base class members inside the child class. So implementation that you have already seen, and I'm sure that that we need to implement all those things in using the circle class and triangle class. These are the methods of the area. So this is what you can say, that this is something which I left with you. So you need to implement all those circle class and the triangle class and the rectangle class that you need to implement, so that you can practice the virtual classes and the polymorphism. So that these are few references for this particular specific lecture, and thank you. Have a good day. Bye.